Hello and welcome back. In this video, I wanted to look at the underlying code for the node substrate template for the node, and I actually wanted to continue the tutorials, but then again, I don't want anything to feel like magic, and I think we can check at the code ourselves, the underlying code ourselves. So I've already opened up my VS Code at the branch that we were on, and this is it. It's the substrate node template. This is the readme section. So let's get started. Okay, the first thing we see at the readme, we see that this is a fresh substrate node ready for hacking. A standalone version of this template is available for each release of Polkadot in this repository. Parachain template is generated directly at each Polkadot release branch. Okay, so this get started section. So we'll skim over this and go directly to the template structure. Okay, we read a substrate project such as this consists of a number of components that are spread across a few directories. The first part of the template structure is the node. Okay, a blockchain node is an application that allows users to participate in a blockchain network. Substrate-based blockchain nodes expose a number of capabilities, such as networking. It uses the lib2p2 networking stack. That library is a peer-to-peer communication, peer-to-peer. Let's actually navigate to it. Run your network applications free for runtime and address services independently of their location. It's a peer-to-peer open networking implementation. I'd say basically that's how I understood it. Understood it. Okay. The next part, consensus. Blockchains must have a way to come to consensus on the state of the network. Substrate makes it possible to supply custom consensus engines and authorships. Okay. So the node provides networking, consensus, and an RPC server. A remote procedure call, RPC, is used to interact with substrate nodes. This allows it to interact with other nodes within its network. I'd guess that the reason why that communication is necessary is in order to maybe for purposes of consensus and also for purposes of I'd say consensus. Okay, there are several files in the node directory. Take special note of the following: chain spec rs. This is the chain specification. Here it is. This is the node src. Chain spec rs. It's a relatively small file of 157 lines. What does it do? A chain specification is a source code file that defines a substrate chain initial state. Chain specifications are useful for development and testing and critical when architecturing the launch of a production chain. Take note of the development config and the testnet genesis function. Okay, so first of all, we import a runtime with all the configurations for balances, genesis, grandpa config. Okay, svc service, substrate service starts a thread and spins up the network client, and extrinsic pool manages communication between them. Okay, chain type, the type of chain, Let's check out the chain types. There's a development chain, there's a local chain, there's a live chain, and then there's a custom chain. Okay, what we used in the previous video is a development chain. Okay, consensus, primitives for aura. I don't know what aura is. We'll check on it later. This looks like a name for, let's check what that is. It looks like a name for a cryptographic. It's a signing algorithm. It's a key derivation and a signing algorithm, okay? Consensus, grandpa, authority ideas, grandpa, core, pair public, okay. The URL for the telemetry server. Okay, specialized. So chain spec is an alias for the Genesis spin. Okay, it's a chain specification like we was discussed here. That is what was it? A chain specification is a source code file that defines a substrate chain initial Genesis state. Essentially, this is what they were referring to. Generate a crypto pair from seed. Okay. We provide the seed and then we're given with the pair, which is the public key and the private key if I'm correct. If you look at the pair, what do we have? Well, the public. Oh, which one is the public? Okay. Okay. I think this is just cryptography 101. Provide the seed. We generate we generate a key. Okay, what I read here was that key derivation and signing algorithm. So basically, this is what we're doing. We're generating keys and generating hashes for our public and our private. I don't know if I've not seen private anywhere, but that's the the general gist of this bit. Then we say that the development config is important here. Take note of the development config in the testnet Genesis functions. These functions are used to define the Genesis state for the local development chain configuration. And these functions identify some well-known accounts and use them to configure the block's initial state. Let's go to the well-known accounts. Like, this is something that we should investigate. Okay, well-known accounts. So it got us to the subkey. The subkey program is a key generation and management utility that is included in the Substrate repository. You can use the subkey program to perform the following tasks. Okay. Generate and inspect cryptographically secure public and private key pairs. Restore keys from secret phrases and draw seeds. Sign and verify signatures on messages. Encode a transaction. Derive hierarchical deterministic child key pairs. I don't think that was really useful to us, but these functions identify some well-known accounts and use them to configure the blockchain's initial state. Okay, maybe there needs to be an update on this link. So that's basically what the chain spec does. It provides the testnet Genesis function and the development config. Let me close that up. So the development config creates a chain specification from Genesis, and returns the chain specification. Testnet config also does the same, but the difference is this is a development config and this is a configuration that's a bit different. It's of type local, chain type is local, and this one chain type is development. Testnet Genesis, configure initial storage state for frame modules. Okay, moving on. Service.rs, this file defines the node implementation. Service.rs, it's like 300 lines. Service and service factory implementation, special service. Okay, so let's go back to the readme. This file defines the node implementation. Take note of the libraries that this file imports and the names of functions it invokes. Okay, so the libraries it has imported are client interfaces, authority round, consensus in Substrate. Let's investigate that. Aura Substrate. Aura Substrate Polkadot. Maybe even Stack Overflow. In Substrate, what is the difference between Babe, Aura, and Grandpa? Substrate supports pluggable consensus, so a developer can choose from among several consensus algorithms. It comes standard with four algorithms. So these are consensus algorithms. Okay, sure enough, we have consensus Aura, consensus Grandpa. Okay, what's next? Some of these, e.g. Babe and Grandpa, can even be used together in a single node. What are the differences between each consensus algorithm and which ones should be used together? Okay, so the answer provided here, the only answer provided anyway. Okay, let me upvote this question. It's a nice question. For a blockchain to be live, continue growing and adding new transactions, two things must happen to solve the problem of distributed consensus. Typically, these jobs are performed by full nodes, as in the case with the default Substrate node. There's block authoring and block finalization. Nodes create new blocks. Each new block contains a reference to a parent block. When forks appear in the chain, nodes must choose which side of the fork to consider the real or canonical one. Once a block is finalized, the canonical chain will always contain it. Okay, the finalization is what we looked at here. If we navigate back to the if when a node was added, when the block number increased, it means that a consensus was reached about that state of the chain and the block was finalized as part of the last block in the chain. That's why the number increased. Okay, so let's just have a general overview of the block authoring algorithm. I would say not algorithms, but it's a little bit more. Okay, let's just look at what this part of the answer says. And always, as always, don't take whatever we read on Stack Overflow, don't take it as the absolute truth. I will go back and do more research on the matter, but let's just have context of what Aura is and what these other algorithms are, because to me, back when when I was running my node, and I checked on this part on using Grandpa authority. For me, it was anyone's guess. I didn't really know what Grandpa was, but at least now we are digging into the implementation of the Substrate node. Okay. and Aura too. We'll know what Aura is. Aura primarily provides block authoring in Aura, and we said block authoring is where we create a new block such that the block contains a reference to a parent block. So finalization is a way for finalization is like a way to achieve consensus, and authoring is just the creation of the block itself. So Aura primarily provides block authoring. In Aura, none set of authorities are allowed to produce block. The authorities must be chosen before block production begins, and all authorities must know the entire authority set. Okay, let's not go into it. Babe also primarily provides block authoring like Aura. It is slot-based consensus algorithm with okay, also it's a block authoring let's say mechanism. Okay, then there's proof of work, also provides block authoring. Okay. So all Aura, Babe, and proof of work are block authoring algorithms. Then we go to block finalization, which I'd say is interchangeable with having rich consensus. Probabilistic methods, which are the block authoring mechanism. Longest chain rule. Okay, I've heard of that before. Where the longest chain is will generally be the most. It's if a chain is longer, it means that it's more secure. Something to do with you cannot what? Okay. Let me just check. Let me just check it instead of. It is less vulnerable to attacks because it's like really strong because of its large number. It cannot be broken by an attacker. Something like along those lines. Yeah, with each new block that is added to the chain, the probability that will be reverted decreases, approaching zero. Okay, generally that's the idea. Okay, Grandpa provides block finalization. However, Grandpa does not author blocks. It just listens to gossip about blocks that have been produced by some authoring engine, like the three discussed above. Each authority participates in 2 rounds of voting on block. The details. Okay, I will go to the details of the Grandpa block finalization method details later. Okay, so I think we have some good a general good grasp on that. The next part is okay, where were we? The file defines the node implementation, which is generally the authoring and the finalization method. The authoring here we were using Aura, and the finalization, consensus finalization, we're using Grandpa. Okay. And the names of the functions in particular, there are references to consensus related topics such as block finalization and forks, and other consensus mechanisms such as Aura for block authoring and Grandpa for finality. Okay. I think I'll stop the video at this part, and in the next section, the next time we'll look at how we'll look at the runtime itself for the Substrate node. I think the information we got, although we haven't like dug into the actual nuts and bolts of how it works, we've just, at least we have a general grasp, not albeit not really a good one. We can at least explain away how the node works from in layman's terms and from a high level standing. So it's been a pleasure, and I'll see you guys in the next one when we discuss about the runtime. Bye.